Welcome, auditors and IT professionals. Today we are diving into the core of the information systems audit process, execution. Specifically, we will master the critical art and science of audit evidence collection. Without solid evidence, an audit is merely an opinion. Let's get started on building your toolkit for gathering irrefutable proof. Let's situate ourselves in the audit lifecycle. You've completed your planning, you know your scope, your objectives, and your risks. Now we move into execution. This is the fieldwork phase. As an IS auditor, your primary goal here is to gather sufficient, reliable, and relevant evidence. Think of execution as the bridge between your audit plan and your final report. If this bridge is weak, your findings won't stand up to scrutiny. We aren't just looking at screens, we are managing a project. You need to track your resources and timelines. During this phase, you will be performing two main types of tests. Compliance testing to see if controls are working, and substantive testing to verify the actual data integrity. Today we focus on the fuel for these tests, evidence. Looking at this workflow, we start with planning on the left, which feeds into our focus area, audit execution. Inside execution, highlighted in pink, the central engine is evidence collection. This splits into two streams, the how, using manual techniques and computer-assisted audit tools, CAATs, and the what, performing compliance and substantive testing. Finally, all of this work consolidates to produce the audit report. You cannot get to a valid report without passing successfully through execution. So what exactly counts as evidence? It's not just a stack of paper. It is any information that supports your audit opinion. It includes what you see, observations, what you read, documentation and logs, what you hear, interviews, and the results of your own analysis. But be careful. Not all information is good evidence. We adhere to specific standards. Evidence must be sufficient, meaning you have enough of it to persuade a reasonable person. It must also be appropriate, meaning it is relevant to your audit objective and reliable in its source. If you are auditing a firewall configuration, a verbal assurance from an admin is evidence. But is it sufficient? Likely not. You need the configuration file itself. Visualize audit evidence as this central core. Branching out, we see the different forms it takes: observations of physical processes, documents like logs and configs, interviews with staff, and your own analysis. On the other side, we have the criteria that validate this evidence. It's a balance of quantity, is it sufficient, and quality, is it appropriate? Under quality, we check for reliability, relevance to the objective, and usefulness. You need to check all these boxes for your findings to hold water. Not all evidence is created equal. How do we judge reliability? First, look at independence. Evidence from an outside party, like a third-party security assessment, is generally more reliable than an internal memo. Second, qualifications. If you are reviewing complex code, an explanation from the lead architect is more reliable than one from a junior support tech. Third, objectivity. A system log showing a login failure is objective, an admin telling you we rarely have failures is subjective. Finally, timing. Does the evidence relate to the actual period you are auditing? A policy written today doesn't prove compliance 6 months ago. Ideally, you want evidence you generated or observed yourself. That is the gold standard. Let's walk through the hierarchy of reliability. At the top, we have direct auditor observation. If you see it or test it yourself, that's high reliability. Next down is independent third-party evidence, like an external SOC report. Then we have internal documentation, which is good but depends on the organization's internal controls. At the bottom is oral representations, things people tell you. Note the flow. High reliability is used for validation, whereas low reliability evidence, like interviews, requires corroboration. Never rely solely on what you are told. Now, how do we gather this evidence? We have standard manual techniques. Inquiry and interviewing are your starting points to understand the who and what. However, people might tell you what should happen, not what does happen. That's why we use observation, actually watching them perform the task, like a badge entry or a change management meeting. Inspection is the bread and butter of auditing, reviewing the physical or digital records, configs, and logs. Reperformance is powerful. You basically do the control yourself to see if you get the same result as the client. Finally, the walkthrough combines these to trace a single transaction from initiation to completion to verify the whole flow. This decision tree helps you pick the right manual technique. Start with your objective. Do you just need to understand a process? Use inquiry interview. If you need physical or documented proof of that process, move to observation or inspection. If you need to verify the logic or mathematical accuracy of a control, use reperformance. Crucially, notice the arrow from inquiry back to the other methods. Always corroborate what you hear with what you can see or test. Often you can't check everything. You need sampling. You have two main approaches: statistical, which allows you to mathematically project errors to the whole population, and non-statistical or judgmental, which relies on your risk perspective. For as auditors, attribute sampling is key for compliance. It's a binary pass-fail. Did the change ticket have approval? Yes or no. Variable sampling is used more for substantive testing of values like dollar amounts. If you suspect fraud, you might use discovery sampling, where finding just one error is critical. If controls are very strong, stop or go sampling allows you to finish testing early if no errors are found. How to choose your sample method? Start with your audit objective. If you are testing controls compliance, you go down the attribute sampling path. If you are testing values, substantive, you choose variable sampling. If you are hunting for fraud, take the discovery sampling route. Under attribute sampling, refine by risk level. If risk is low and you expect 0 errors, stop or go is efficient. If risk is high, stick to a robust fixed sample size. In modern IT environments, manual testing isn't enough. Enter CAATs, computer-assisted audit techniques. These allow us to test 100% of a population, not just a sample. GAS, Generalized Audit Software, helps us extract and analyze data independently. For more advanced real-time assurance, we use continuous auditing. Audit hooks can flag suspicious activity instantly. An integrated test facility, ITF, lets us run test data through the live system to verify processing logic without corrupting real data. SCARF, System Control Audit Review File, collects specific data points for later review. These tools give you independence and depth. This diagram shows how CAATs integrate with the system. Live transactions enter the application. While they flow to the database normally, audit hooks might siphon off alerts to a log, and SCARF modules might collect data into a review file. Simultaneously, you can inject test data via an ITF to verify processing logic. As the auditor at the bottom, you use GAS to pull data directly from the database, and you review the logs and files generated by the automated tools. When collecting evidence, especially for forensics, you must follow the evidence lifecycle to ensure admissibility. It starts with identification, knowing what to look for. Then collection. Here you must use tools like write blockers to prevent altering the data. Next is preservation, hashing the data to prove integrity and storing it securely. Analysis must always be done on a copy, never the original, to avoid contamination. Finally, presentation of findings and return of the asset. Throughout this, the chain of custody is paramount. You must document every handoff. If the chain breaks, the evidence is worthless in court. Follow the flow of evidence. We move from identify to collect. Notice the constraint here. Use a write blocker to ensure integrity. Then to preserve, where hashing and chain of custody documentation are vital. Next is analyze, where the rule is work on copy. Finally, we present and return. Following this linear path without deviation ensures the integrity of your audit findings. We conclude by bringing it all together. You've used interviews, observations, and CAATs. Now you synthesize this evidence into findings. Remember, if you can't back it up with the evidence we discussed, it shouldn't be in the report. Your report should clearly state your methodology. Did you use statistical sampling? Did you use an ITF? Finally, the process doesn't end at the report. You must follow up to ensure risks are mitigated. Effective execution, grounded in rigorous evidence collection, is the hallmark of a professional CISA auditor. In this final stage, all your data enters the evidence pool. It goes through analysis to become draft findings. You must ask the critical question: is it supported by evidence? If no, you discard or retest. If yes, it makes it to the final report. Management responds, and you perform follow-up. This cycle ensures that your audit adds real value to the organization.